Hello, and welcome to this 90-second Elastic Meetup. I am very, very pleased to be here in this beautiful space hosted by Radis Consulting, so merci for that, as well as the logistics provided by Elastic. I really appreciate the role Elastic has played in our event today as well. As David has said, I am Lucia Cerchie. I work for Confluent. I am visiting from the United States, and again, I'm just so happy to be here in this beautiful venue. We can see the Eiffel Tower right over there. In my free time, I code even more and do web development. You know, at Confluent, I'm deep into these technologies like Kafka and Flink, but it was actually my web development hobby that led me to make this little project. I make websites for my friends and family, and I thought, why not make a website that teaches us about Kafka, Flink, and Streamlit? You can look at it using the QR code there. You can also check out the GitHub repo with the code behind it by checking out these QR codes. I'll give you a moment to take a look. So the overall structure of our talk. First, we'll briefly go over a couple of things about data visualization and different types of data. Then we'll cover an overview of Kafka, Flink, and Streamlit. I'll share some things I learned in making this project, and we'll have a bit of Q&A. You cannot collect, format, or visualize data without saying something about it. I hold this belief very strongly because even at the collection stage, we're filtering the data by choosing what data to collect. Then when we format it, the format kind of determines the end product, and in the visualization, we're saying something even more. So if you take a look at these two bar charts, it doesn't really matter what the data here is referring to, but you can see on the left, I selected a gradient of reds, and on the right over there, there's different colors. And even with that color selection, I've said a couple different things. When I choose a gradient, I'm pointing out the sameness of those categories. And if I choose different colors, I might be emphasizing the difference of the categories that are visualized by those bars. A side note that I kind of find interesting is that in different cultures, the color red can represent either debt or profit. So it's good to know when you're creating a visualization like this, maybe you want to choose a neutral color. If you're interested in reading really deep data visualization stories that say something very strongly about data, you can look up The Pudding or Nightingale magazine. These two magazines are very well put together in my opinion, and I read them in order to develop my own taste in data visualization. So what does the chart we're looking at today say? Looking at this data more as a way to learn about Streamlit, Kafka, and Flink than about anything else. But I would love for you to think about this idea of saying things with data visualization, maybe share some things that this chart could say more strongly with me, or share your ideas about telling your own data stories. So we're going to take a closer look at the 3 technologies in the title of this talk. But before we do that, I'd like to talk about what are, in my mind, 3 categories of data visualization. To me, the structure and technology of a data visualization project is determined by how the data arrives. So what if you have data at rest? This is the kind of data that is sometimes in a spreadsheet or a .csv file. Once we load it, we can format it just the once and make assumptions about what's in there. This type of data doesn't have to be in a spreadsheet, but generally it's not fresh, it's in a batch. In the middle, that icon, I hope, represents dynamic data. I think of REST APIs or GraphQL APIs. If the data is not cached or the result needs to be dynamic, like as the result of a user interaction, then we have to load this data either upon application start or in response to a user event. So while this is dynamic and a little more fresh than something that's just loaded once in a batch, it is not live. Last, my very favorite type is streaming or live data. this data happens in real time. We make a connection to the stream upon the application start, and then we need our chart to react responsively to each event as it comes in. This can be very tricky, but luckily we have some technologies to help us on the way. And this is where we enter into our overview of Kafka, Flink, and Streamlit as technologies that can help us do this. So recently, I got the chance to bring all of them together in this application. This is a graph of what the application does. If you'd like to visit the website, you can visit the QR code. I took live data that comes in from an Alpaca API WebSocket and piped that to a Kafka topic. Then I did a bit of processing with FlinkSQL. That processing resulted in a new Kafka topic, and that was surfaced to Streamlit, and then surfaced to the user interface via Streamlit. So Kafka is what stores our live data. It's an open source event streaming platform. It's predicated on this idea of events, which can also be called messages or records depending on the context. But I think the main thing to focus on, since we're doing an overview here, is it stores these events in its data structure, which is a log. And it's that log is called, within the context of Kafka, a topic. Now, each message has a piece of information called an offset that tells us its position in the log. As you might expect, it starts with offset 0 and continues from there. One time, I forgot this. I'm an American, so we start our floors on floor 1 instead of floor 0. And I wrote some logic that depended on the first message in the queue being, or in the log, pardon me, being message 1. And I found that I'd committed the old off by 1 error. Here's a topic with 3 partitions. Each of these partitions can live on a different node or machine in the cluster of servers, and this enables Kafka to scale. Now here I have a cloud. Today my data is living in Confluent Cloud, but this project could certainly be executed using open source Kafka on a local machine or using virtual machines. How do these messages get into a topic in the first place? This is the role of something called a Kafka producer, which is an application that sends messages to a Kafka topic. We can create producers using Kafka clients in many different languages, including things like Go, even Groovy, I believe. But today it's in Python. A note on the Kafka topic, which I had already set up in Confluent Cloud. I instantiated a producer and set up a JSON serializer using the Apache Kafka Python client, then fed it in using the topic name to define which topic it gets fed to, and that's the same as the stock name in this application. Then, how do we get data out of a Kafka topic? That's the role of a Kafka consumer, which again, we create with a Kafka client. Again, today it's in Python. If you would like to run through a short tutorial on setting up Kafka producers and consumers with Python, you can visit Confluent Developer, which is an educational website, and use that QR code to follow along. The last sort of piece in the Kafka puzzle is the schema registry, or at least the sort of piece we're covering today. Kafka is a very wide technology that covers a lot of topics, but something that I would like you to know about today is the schema registry. This schema registry makes sure that data exchanged between consumers and producers is maintained in the same format. That way, you're not writing logic with your consumers to make sure they're not broken. The schema maintains the data format. It also helps if you're at a very large company and you have one team with a producer and the other with a consumer. This schema registry can almost act not just as a data contract, but a social contract between these teams. So that, in summary, is sort of the main structure of Kafka. There is much more to it. There's a wide ecosystem of tools. There is another way to process Kafka streams separate from the one I'm talking about today, which is called Kafka Streams. And there are best practices for distributed computing that are specific to Kafka, but we have just a few more minutes left for finishing up the talk. So let's move to Flink, which is the technology that I use to process the data coming into the Kafka topic. Many people think that Flink is an open source tool for processing real-time data. That's true. I think it's speaking a little loosely. It's a platform for performing stateful computations over bounded and unbounded data streams. So here I'm borrowing a little chart from the docs to illustrate what this actually means. Bounded streams have a beginning and an end. Processing them is also known as batch processing. You can do this out of order and then sort them. However, with unbounded streams, they have a beginning but no end. So we ingest the events in order to perform logic about, say, like look-back windows and things like that. There are 4 levels of abstraction in Apache Flink. There's FlinkSQL, which is the highest level of abstraction. You can execute queries over tables that you can define in the table API as well. FlinkSQL is what we're using today. I have dipped both into FlinkSQL and the table API in my exploration of Flink. I am doing that on purpose because I have heard from more than one expert in the Flink community that when you're learning Flink, you start at the highest level of abstraction and then it helps to dig deeper as you go along. So FlinkSQL is ANSI compliant. It allows us to declaratively express data transformations and analytics on streams of data. On the screen here, we have an example of a FlinkSQL statement. It is what I used in this application, and I'll go into the details in the next few slides. In the first line, we're inserting the result into the destination table. On the second, we select 4 values from the source table. On the third, we specify the row table, which is the interval that we're averaging messages over. Here it's 5 seconds. And the watermarking strategy via the descriptor syntax. That, if you're wondering about that $row time, that is the value of the Kafka record timestamp, which is provided by the technology in Confluent Cloud. I executed this query in Confluent Cloud. Then we group the results by the symbol, window start, and window end columns. Now, once my messages are processed by FlinkSQL in Confluent Cloud, a topic with the changes made by FlinkSQL is automatically made. This is something that exists in Confluent Cloud. It's a behavior there. It is not the same in open source Flink, I'd like to mention. Now, within the context of my project, we get the messages from that topic in Confluent Cloud into the Streamlit app by instantiating a consumer with the Python client and subscribing to new messages. Each message that is now coming in is that messagery variable at the bottom there. Now an overview of Streamlit, which is where that process stream finally surfaces to our eyes. Streamlit is 2 things in my mind. It is a component library with many components, which makes it a straightforward process to construct a front end, even if you haven't done a lot of that. I appreciate it even as someone who has made front ends with just low-level JavaScript. It is, with levels of abstraction, we go higher when we need to get something done quickly and beautifully, and then lower when the details require the lower abstraction. The other thing is that it's a deployment service. So if any of you have used AWS Amplify or Netlify, deploying using Streamlit kind of feels like that, where you have a branch that you specify. When you push to that branch, the new changes are published to your website. So to recap, my original data source was the Alpaca stock API. I subscribed to the Alpaca WebSocket, piped the data into a Kafka topic in Confluent Cloud using a Kafka producer, processed that using FlinkSQL in Confluent Cloud again. Then I consumed that data and created a visualization using Streamlit. So you might be wondering, since we're at an Elastic meetup, how might we use Kafka with Elastic? And I was thinking about that today. Whenever I'm creating one of these demos, I always think of the different technologies as little pieces in the puzzle, and sometimes you find a puzzle piece that you can replace and create a new picture, which is pretty neat. So while I didn't use it in this specific project, it could certainly be both a source of data and then the place where our data finally ends up. So instead of stock prices, maybe we're figuring out how often documents in Enterprise are being updated, and if they're indexed in Elastic, we can use something called a Kafka connector to connect to that data and then process it and maybe visualize it using our chosen form of visualization. Or we could do the reverse with the Elastic Sync connector. Take in logs and metrics, store them in Kafka, process them with Flink, and use the Elastic Sync connector to visualize, to get them to a state where we could visualize it. I think earlier we had an example of Kibana. Now I'd like to reflect back on this project with 2 short lessons learned. One is Streamlit's usually a single-threaded application, so at first running the consumer and producer just didn't work. And this is something I wonder if that might happen in other visualization tools. I introduced the Python library async.io to run these 2 different threads, and everything worked from there. But again, that's something I had to introduce, and it was a fun problem to solve. Another interesting thing that I learned was the syntax for creating a topic with one partition in Flink when you are using Confluent Cloud and you are using a Flink workspace. It creates a topic with 6 partitions by default, which is a good idea in general to have not just one partition, right? I don't know. Yeah, I'd be surprised if someone had like a Kafka app in production that only had 1 partition total. But since this was a demo and I wanted to keep things simple, I thought, how would I do this? And I found that you would use this distributed by into 1 buckets syntax. There's a README that tells you how to run this project yourself, and it tells you a little bit more about it. I hope you enjoy it. Now, returning to the introduction theme for a moment, visualizing live data is, I think, a fairly new frontier. It brings with it some unique challenges, like how to visualize something in real time. Many visualization libraries have windows that you can use, but the one that I used required some sorting, which was not necessary as the Flink topic was being ingested or the Flink processing was done in order. So there are things like that that are pushing the edges of these data visualization libraries, and I just think it's super fun to talk about, so I'd love to hear about any edge cases that you've had like that in the Q&A, which I'm ready for.